Disco Ladyada. New graphics coming soon.
I
So a little
know.
bit of a preview.
Very cool. Sorry. Hey everybody, it's a sniffly Sunday. I got pretty sick this week. So the baby got sick and then I got sick, and so I'm recovering. But not as much hard work going on this week. I did get a couple designs going here and there, and I did a lot of crosswords in bed. So let's get into it. I did get some prototypes made, so trying to get, like folks noticed the last couple of weeks there haven't been as many new products in the shop because as we did the last big push of the move, my desk moved and like machines moved. I didn't do as much hardware, so trying to get that pump primed because I find a chip, and then a week or two later I get a prototype made, and then I get the PCBs made, and then like a couple weeks later the board's in the store. So like I have to start now getting a whole, and then like in 2 months you're going to see it in the shop. So,
Yeah, the last 2 weeks you've probably seen on our socials. There's a couple coming soons per day. Yeah, she's not faking it, folks.
oh no,
What's funny is the all the sickness just skipped me. I'm not even wanted by the most gnarliest.
I know.
I'm so lonely. So anyways, you've probably noticed how many coming soons we have. So it's delightful for our community because they'll say, "Hey, can I? Are you making this?" And then we kind of right away say, "Yeah, we actually are."
Yeah.
So it's delightful for our community, devastating for our competitors. So
Maybe inspiring for them.
yeah,
I don't know.
maybe. Okay. So let's
Don't make me laugh too much.
I'm not going to make you laugh. This is serious business. Okay, what do you want to show?
Okay, let's go to the computer. So the first one, I got samples of this a couple months ago. So folks have seen my AS737. Wait, what was it? Yeah, 7341 10 channel light and color spectrometer. It's actually a cool sensor. It has like it says 10, but it's actually like 7 channels of different diodes, very, very tuned to individual light frequencies. So there's a new version of this sensor called the AS7343, and it's like 14 channels. So it has 4 more channels, and it's like not that much more expensive. And here's the thing about all these like boards that I designed this week is like they all use the same footprints as the previous. So as long, I just verified the footprint was the same, and then I just updated the silk screen and just ordered, new PCBs. Or I'm just going to recycle old PCBs so I have them. So the S7343, same I2S interface, hopefully similar driver, so I don't have to rewrite that whole driver over. I think actually that driver was written by Brian. Hopefully I don't have to adapt that driver to too much to add the extra channels, probably just command. More Spectra. People really like the 7341, so hopefully the 7343 is an easy upgrade. Next up, the TMF 8828. Okay, so this is a multi-zone time of flight. So when people think of time of flight sensors, they normally think of the VL53 series, the L0X, L1, L5, that whole family from ST. And these are great sensors and everything, but it's always good to have competition, good to have other options. So in addition to the ST ones, there's a couple other companies that are coming out with time of flight sensors, including this is AMS Osram. So the TMF 8828 TMP TMF 8x8 zone, fairly small. Osram makes pretty good stuff. So, oh wait, there's the website moved. A couple different versions available. The one thing that is definitely true about the VL series is the firmware is a little bit like the driver side is a little like gronky. Like you kind of have to use their code. And I don't think we have Circuit Python for one of their drivers because it's so complicated. Because it's like this extremely intense driver. So I'm just hoping the TMF series might be a little bit easier because that would be a good option. But also like the price is very competitive. And this one, they can do 5 meters at 30 hertz. And the VL53 series, I think, tops out at 4 meters. So, like, that's pretty cool too. Good competition. I'm liking it. So, all I squared C. So I designed a version. I basically, it uses 1.8 volts. No, it's a 3 volt chip. So it's more compatible with 3.3 volt. It has some GPIO. You can you use enable to change the I squared C address. They looked at the VL53 series and they're like, well, let's just try to do a better version. So I made a breakout for this. That's kind of cool too. And then what's afterwards? Okay, then the TCS 34303. So this is actually even though this sounds similar to TCS, it doesn't even have stock anymore because it got discontinued. The TCS 34725 is actually one of our first sensors designed by K-Town. The great RGB sensor, but got discontinued. But he kind of this is one of the first sensors that pioneered this oh, it's going to be rectangular with 2 mounting holes, which at the time was innovative because nobody had mounting holes in anything, especially always in the same location. So the TCS 725 was an early sensor from I think it was AMS. People really liked it. We used it in a lot of tutorials. But what's interesting about the TCS 34303 is the TCS 34303 is it's a tri-stimulus sensor and it gives CIE data out. The data sheet. So it's like it doesn't give you RGB output. It gives you CIE XYZ output. So on the CIE chart, which I think might, to be honest, I'm not 100% sure why would be preferable. But perhaps it's just more accurate because it's a new conversion between CIE space to RGB space and back. So I thought it was kind of interesting, and maybe for photography or videography needs, this could be pretty useful. So I made a breakout for this little guy. Basically, these are a lot of chips that I basically ordered samples for over the chip shortage, or they developed around the chip shortage, and I ordered samples, and then I never got them, and then they showed up 6 to 8 months later. So this one is pretty straightforward. 1.8 volt chip. Also made a stomach QT board for it, and then I just put a neutral white LED for illumination. Although I actually don't think I think for this you're measuring light, not bounced off light, and so you would probably not need illumination. But I had the LED on there anyways, and it's no biggie. So I did that one, and then this one was a pretty easy one too. This is a bottom ported microphone. So this is the ICS 43434, which is a really satisfying part number. This is an I2S microphone from TDK. We have one already from it's the SPH something. I can never remember these part numbers. SPH 06545 from, geez, who's this from? Knowles. They make good stuff. I2S digital output microphone. I'll talk about this a little bit more in the great search, but this was thankfully this part, the ICS 43434. I don't know which came first, the SPH or the ICS, but they're pin compatible. Just another example of I made a breakout, but not really. What I did is change the silk screen and just verify that the part numbers, the part shape and the pads are all in the same location, and then get samples of the chip, and then test out prototypes. But it should work exactly the same because I2S is a standard. Okay, and then how are we doing on time here?
You got 11 minutes.
Let me just show off one quick tester, and then we'll go on to the great search and some other programs. Okay, so the good news is like for the overhead. Pardon me. I got some stuff for the RP2350 coming in, so we're a little delayed on it because again our machine line moved and everything kind of took a little longer than expected. But these are the first boards with the RP2350 that are not hand soldered. Yay! So looking really good. Oh, this is the debug port. So this is kind of our first feather. PSRAM isn't soldered on yet. We'll probably make a version with PSRAM soldered on. Next, we're just taking it easy because I want to make sure that there's two PSRAM chips that are kind of popular, a 2 meg and an 8 meg. I want to see how much RAM PSRAM people need. I also have to get a bunch of these 2 meg chips because they're oddly hard to get. And then there's this cool HSTX port, which I also got prototypes of my HSTX to DVI output. Although, now that I think of it, I want to change the design a little bit. But this would let you do, you could have NeoPixel output, or you could have DVI output, or you could have it control, I don't know, LCD or whatever matrix, LED matrices, maybe. So this is DVI output. It has a little extra circuitry because you need a little 5-volt booster, level shifter for I2S because it's 5-volt level, some inline resistors, but you get your nice little DVI port connect to HDMI display. So I have to do the tester. So this is the tester. I have to solder on this connector because I test the HSTX line. You put this on here and then you program it. And I'll be honest, I actually haven't verified that our Pico burning code can do HSTX. But also I was waiting till Arduino Pico added the Phil Hauer Arduino Pico core added support for the RP2350 because I didn't want to write the code in plain makefile Pico SDK code because I'm lazy. I have all the code done in Arduino ready to go for the RP2040 feather. I don't want to rewrite it for the 2350. So that's going to be this week's project. So hopefully by next week's Desk of Ladyada, this will be done in the shop. So sign up. This is product number 6000. You want to go to the computer again and I'll quickly show it. Sign up. If you want to pick one of these up, they will likely be in the store this week. Hopefully by Wednesday's show, but if not, then by Friday for sure. Assuming I get over this plague. Okay, so that's from the Desk of Ladyada. So we want to go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you so much, DigiKey. Every single week, Ladyada is the power of engineering to help you. Yes, you find the things on digikey.com. Ladyada, what is the Great Search of the week this week?
Okay, this week we had a request to please add a breakout for the ICS 43434, which is like a really satisfying part number. And this is a I2S MEMS microphone stocked at DigiKey, and you can tell it's quite popular because they have 360,000 of them in stock, and that's a lot for any kind of microphone. And I thought maybe we covered I2S mics on the Great Search. We've talked about I2S mics before, but not looking at the latest and maybe making a design with them. So we actually stock a couple different MEMS mics, and we did a Great Search for, I was like, oh, did we do this before? We did one on an I2S ADC, so you have to use an electret mic or an analog mic into this chip to get signal. We did an I2S mono amplifier output, and we did a MEMS analog mic. So the analog mic, oh wait, let's pop. There's basically 3 types of MEMS microphones. And MEMS microphones are preferable to electret because they're not less expensive, but you can pick and place them, so there's less hand work and less hand soldering, whereas electret mics can't go through a reflow oven. You have to get wave soldered. So we stock the SPW 2430, and this is a fairly inexpensive analog MEMS mic. And this MEMS mic, like I said, is pick and placeable. You give it 3-volt power. The output is an analog voltage, but the analog voltage is kind of low. It's like 100 volts peak to peak. You'll almost certainly want a amplifier chip, an op amp, to go with it to give you like 30, 50, 100 times gain to get you closer to like, 0 to 3.3 volts DC biased analog output. And actually, for folks who've been around for a long time, if you remember the video series I did on the design of the Circuit Playground Classic, you can see here, there's a MEMS mic, that SPW, blah, blah, blah. And then this is I don't remember, it's a TS922 or something. It's a low cost dual op amp to create the bias voltage and then give myself some, I think, 100 time gain, maybe 47 times gain into the analog input of the Atmega chip. And the reason I did this is because I needed a microphone. I didn't want to have any hand soldering. And the Atmega 32U4 does not have PDM or I2S input. That's important to note because preferably you can use a PDM mic. And PDM mics are kind of the same low cost as a analog MEMS mic. But instead of giving you an analog voltage that you then need to like amplify or filter and you need an ADC, they give you a digital signal output. And you clock them in and they give you this digital signal output. And the digital signal, it's like kind of a funky, it's a kind of a funky, weird signal. It's the output of the internal comparator for the capacitance on the MEMS diaphragm or whatever, or like the voltage change of the diaphragm. It's a pulse density output, so the pulse width changes with the analog voltage. So let's see if I can see like, yeah, it looks like this. So you get a digital output with zeros and ones. And like if you low pass filtered it, you would get an analog output, but you can do the low pass filtering using fully digital convolution rather than having to do anything analog. They don't have to do any analog filtering. So it's like and a lot of chips these days, like STMs, NRF, RP2040, ESP32, they often have a PDM peripheral, or you can recycle one of their existing peripherals into doing PDM input. You then have to do the filtering, which is a little bit of a pain in the ass, but I've written some code for it that folks seem to like. And then you get the output and it's good enough, basically. But if you want to connect a microphone directly into something like a Raspberry Pi computer, or another single board computer, or another chip that has I2S input, normally you would have to use an I2S ADC and then have an electret mic or an analog mic, and then you'd have the conversion, but if you are like, you want something very small space setup, you don't want a separate codec, you can get microphones that just have pure I2S output, which is like kind of amazing. They basically like slapped a little chip on there that takes the PDM output, converts it to I2S, because like there's nothing, like there's a separate circuit inside. They're going to be more expensive than PDM or analog MEMS, but they're much, much smaller and they're really easy to use because there's no I2C configuration of the ADC. There's no analog filtering or op amps. There's no PDM like peripheral and filtering and quantization and convolution. The data comes in exactly as needed for almost any I2S input, and they're ready to go as is. So it's like kind of a trivial setup. So a lot of people do like using these. So like I said, we have the SPH 0645, and so this person was like, "Oh, can you make a breakout for the ICS 4343?" And I was like, "Okay, I can make a breakout." Actually, turns out that this has the same pinout as the SPH 0645. So it's actually, I'm going to just spin the board over and just place the ICS on it, and it should be just fine. But I thought, let's look at other I2S microphones that might be available. So I actually I kind of, it's an interesting because I kind of went around slightly a different way than usual. So I looked for I2S mics, and then, I got here, and to be honest, there's not that many, it's kind of like a slim pickings, right? So I look for only active. And then you see it's there's a couple options. There's the SPH that we know and love, the ICS 4343, which is the requested piece. And there's also this other one, which, wasn't clear what the deal is. I was like, oh, you know what? Like, I thought, like, let's check out TDK InvenSense, their website for I2S mics and see what's up. Because sometimes when you're searching for stuff, DigiKey like tries to do their best to categorize everything, but it's like it's hard to get everything perfect. So if you want to specialize things like this, where obviously they don't have that many options, there's like only 5 things that they stock. Sometimes I go to the website of the company that makes the thing and then search, because sometimes it could be categorized under a different category. It might have like something that escaped my search. Or it could be a special order item, in which case DigiKey will get it for you. You just have to request it. Usually they get it within a week or 2. So I found this. I was like, okay, cool. This is available. And then I clicked back on digital mics, because I was like, well, let's see what digital mics TDK, because TDK and InvenSense, like, they're really good at sensors and stuff. So one thing that I noticed is they said down in the NRND area that a couple ICS chips, including the 43432. So, and then I've seen a few people use the INMP series, but these are all not recommended. They actually recommend the T5838. So I was like, okay, let's go back up here and check this out. So the ICS 4343, they're still in production. You saw there's 360K over at DigiKey. This is like a super popular chip. And then with digital 24-bit digital output, which is super cool. Signal noise ratio 65 dBA, some low frequency cutoff. But I was like, well, what else do they have here? So some of these are PDM and some of these are SoundWire, which I don't know what that is, but that's not I2S. They only have one other chip. This is the 5848, which I think was the one. So the 5838 was the one recommended, which is PDM, which is not what I want. So it looks like there's a new chip available coming soon. Let me see, it's available on DigiKey actually. Ooh. So it's not available yet, but it looks like I might be able to request it. So I'm actually kind of interested in this chip because, I'm making a breakout board for that ICS 4343. But it definitely looks like everyone is like recommending that we move to the T53 series, and the 38 is PDM, not I2S. So what I'm going to do is, this is in production. Don't know why it says contact us. Looks like maybe it's not in stock immediately. But what I do like is it has a slightly better signal to noise ratio and sound pressure level support. So this could be a really nice microphone. So what I'm going to do is I'm going to sign up for stock notification, and I'm going to contact DigiKey and see if I can get this stocked, because I would like to make a breakout with this one. So this is actually my pick. Usually, like during the chip shortage, I'd be like, you're never going to get this part, but it sounds like it's maybe just a little back ordered. Other than that, you can also get the ICS 43434. But it looks like this might be the next generation of high quality I2S MEMS mics. So I'm going to get some of these. Maybe in a couple weeks, you'll see me make a breakout for it.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right, Ladyada, you're a trooper.
I know.
Get out of here. You're
I
coughing
am.
so much the camera's going out of focus. We got to get you out of here. Okay, everybody, buy some stuff so we can buy her some Nike.
I need more NyQuil.
Bye.
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 Bye.